Hi guys, welcome to my YouTube channel Unsifar, and we are going to start a new playlist on the Leetcode DSA questions. We'll solve most important questions that comes in the interview and all the important data structures we are going to cover. We'll see the logic of each and every question, and also we'll see the code. For my personal preference, I'll be using C++, but you are free to use any. You can use C++, you can use Java. So let's start. So the first question we'll be covering is in-order traversal in binary tree. So the first things first, what is a binary tree? A binary tree, you can define it to be a tree data structure where each node has at most 2 children. Since each element in a binary tree can have only 2 children, we typically name them as the left and the right subtrees or the subchild or just simply child. So let's see how basic structure looks like. Let's see. There will always be a parent node, and then there will be 2 branches, one to its left side, one to its right side, and the same thing will be repeated over here, and this will be called as the left subtree, and this part will be our right subtree. Okay, so let's see how we will traverse them in the in-order traversal function. So let's see how we will traverse it in a in-order fashion. So let's make a tree. 1, 2. Alright, so you can see this is a tree, and every node fulfills the property that it will always have at most 2 children, one to its right and one to its left. So in order fashion, how do we traverse them? The traversal should look like that. First, all the right children will be printed, then we'll print the parent node, and then all the elements to its right side. This is how we have to print it. So if I would write it, then I can write it. Number 1, we print elements to the right, then we print the root node, and at the end we print the right subtree, and you have to perform this for each and every node. That means obviously this is going to be a recursive function. So how the printing will look like? So we always start from the root node, that is 1. Now we go towards the right side. Towards the right side, we move to the 2. Our pointer moves to the second element. Here we can see it has no left child, so nothing will be printed to when it goes to the left, and also when we go to the right, we can see there is nothing over here, so nothing will be printed over here as well. So all it's going to print is itself. So the first thing is going to print is 2. So for 1, now we have covered the elements to the right, print elements to the right for the node 1. That is done, and the next step is print the root. That means it will print itself. So now it will print itself, that is 1. Now we move towards the right children. So now a pointer will come to the node 3, and now we will perform the same steps for this node as well, what we perform for the node 1. So now 3 again will traverse to all its left subtree. So now 3 will move to the 4. Again, when we come to the 4, same things will be repeated. We won't move to the right here, we will move it when we backtrack it, come back to the node 3, and again we will traverse this part. So again for 4 we have to see we don't print this, again we perform this step, print elements to the right. So now again we move to the right side. So when we come to this point 8, we can see that there is nothing anymore towards its right side, so nothing will be printed over here, and again 8 will print itself because this is what it says for this node to do the second step. So now it will print 8. Now we move to the right side and we see there is no node over here as well. So it will print null. Now it will come back to this node 4. So now for 4 we have done the first step, that was print elements to the right. So now it's going to print itself, that will be 4. And now it will see towards its right side. We can see there is nothing over here. So now again it will backtrack to the node 3. And now we can see for node 3 we have performed this step. So the next step is now we will print the element 3. Yeah. So now again it will move to the next part, that is the last part. For this node we move to the last step, that is print elements to the right. So now it's come to the, so now for 3 these 2 steps are done, and now we move to the right subchildren. So in the right we can see there is 5. It comes to 5, and whenever it comes to 5 these steps will be performed again. So for 5 we have to again go to the elements to the right. So 5 will come to this point. So we can see we have come to the 6. There is nothing to print on the left side. This is what the first step says. My bad, it won't be right, it would be left, sorry. So yeah, it comes to the 6. We can see there is nothing to the left side, so it will print itself. Now it will be 6. Now it will come to the right side. We can see there is nothing over here, so it will go back, it will backtrack itself. It comes to 5, and 5 will print itself, print the root 5. And now it will move to the right part. So in the right part there is 7, and 7 will look to its left. In left there is nothing, so it will come back and then print itself, that is 7. Then it will go to the right part. You can see in the right part there is nothing as well, so it will backtrack itself. So 5 will backtrack itself, and we can see that for the 3 also we have performed all these steps. So now it will come back again, and once we come to the most parent node, then it will just move out of this function. So this is how it looks like, the implementation. So now we'll just see the code part. So before we see the code part, we'll see how the pseudocode should look like. So let's see. There will always be a main function in C++ where we will call the function to print the Inorder traversal. And this is the root node. This root node is nothing, is just the address of this node. This node address is all we need to traverse the remaining tree. So let's make this function in order. How it should look like. We will always pass the pointer because we need the address. So the first thing we'll do is go to the right subtree, and to do this we just have to call it recursively. In order root left, sorry, my bad, we have to go first to the left subtree, and the next step will be we have to print out the current node root value. Let's suppose the value is stored in the variable val, and once it prints itself we have to then move to the right subtree in order root right, nothing. And for the base case, so that it just does not go on infinitely, we have to write a base case as well. If root equals to null, then we have to return, do nothing. So this is how the pseudocode should look like. Let's see a question on this. Yeah, so this is a question, and you can see this is a question of the Leetcode. So this is the question. You can see binary tree Inorder traversal, and in this question you have to do the simple traversal in the Inorder function, Inorder fashion. So this is the main function, or you can So in this, what you have to do is basically you have to return the array in the same order how we are going to print it. So let's see. So first of all, we make a vector of answers. We'll store the answer, and then we call the function in order that we have made. So you can see if root is null, then we just simply return, and then we move to the left side and then print itself. Print itself basically means we are putting the values in a vector, and then we move to the right part. That's all we are doing, and let's run this code. Yes. So yeah, so it has passed all the cases. So yeah, that's all for the video. Thank you for watching.